Hi, this is Kurt, and today I'd like to talk a little bit more about batteries and the maintenance, battery maintenance of the Pure Ego, the carbon fiber scooter, the Hero S5 or S5 Pro model. And to understand how you should treat your scooter, you just have to get a little bit more knowledge of batteries. You probably don't know, or you might know, but in the laptop that you're probably using to watch this video, the laptop probably uses batteries. This is actually recovered from a computer battery pack. I just took it out because I want to recover these batteries. These are older batteries. They had their life cycle, but they're still good. They're still good enough to use as batteries in a flashlight or something else, something that is not drawing too much of a power and where the autonomy is not so important anymore. Now, these batteries are called the lithium-ion 18650 cell. And the 18650 refers to the size. If I just take the size and show you the size of this cell here, the diameter is going to be very close to 18 millimeter, okay? And the length is going to be 65 millimeter, so 6 centimeters and a half. Just have a look at that. So there you go. So that's actually how they categorize these batteries, because there are also different sizes. But basically these lithium-ion cells are used in nearly everything these days. They get a very strong power. They can go up to 30 amps, certain of them, and the newest ones, they can even go up to 3,600 and even 4,000 milliamps per hour. That is a hell of a power. Certainly if you look at the size and power ratio that you get from these cells. Now, something that you need to understand is how you should charge these scooters. But let me just first quickly explain what is inside the cell. I'm going to take an envelope here, but basically you have the insulator between two materials. On one side you'll have the aluminium material, on the other side you'll have the copper material. The aluminium material will actually also have the lithium ion on there, and that's going to be the positive side. The aluminium is called the cathode and the copper is called the anode, and the lithium ion that's on this side of the foam that will actually glue to this insulator will carry the positive side and will carry the energy. So basically they roll up. Now I'm not going to do it with this envelope because this is for a customer. They roll it up and they stick it into these cells over here. So basically that's it. Now why am I explaining you this? Because these cells, they have a specific, they call it nominal voltage, which is actually the general voltage, the average voltage, because the voltage goes up and down quite a lot. It depends on how much current is drawn from the cells, and it also depends, of course, how far the energy has been used up in the cell. But basically they go from between 2 to 2.5 or 3 volts, because certain cells they go as low as 2.5 up to about 4.2 volts. Now why is that voltage important? Because first of all, if I have the aluminium over here with the lithium ion and I've got the copper over here, there is what we call a galvanic current. Galvanic current is when you just use the two materials without charging the energy, and the two materials, the copper and the aluminium with the lithium ion, there will be a difference in voltage. Just the material itself, without charging it, just the material. It's the material electrical difference, okay? And this is going to be between 2.5 up to 3 volts. Now, why is that important? It's very important that you have to understand that if you discharge these batteries and you go below the voltage of the galvanic voltage, you are actually damaging the cells. The lithium ion will go actually through and into the insulator materials, and it's going to create either a short circuit, or it's going to actually make the materials from the anode and cathode release, and it will get trapped into the insulator that is insulating the two materials that are carrying the electrodes and are carrying the energy, storing the energy. So it is very important that you need to understand that going below the voltage that these cells are rated is actually going to damage the batteries. What does this have as a consequence for your scooter is that basically it's very, 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 very bad if you own any kind of electric device, whether it's a electric bike, a car, or scooter, or even your computer battery, to actually draw the current to 0 volts, because it will inevitably damage the cells forever, and you probably have to trash them. So that's why there is something that you need to take care of when you're going with the scooter around and you are actually drawing too much current and you are actually draining batteries to beyond actually the lowest voltage that it should have, below the galvanic voltage of the cells. Now inside these scooters, they are packed together. This is just an example of a battery pack of a computer, and they put them in parallel and some of them in series. Most of these cells in these scooters, they have 2.6 amps per hour, so 2,600 milliamps per hour, and these are 10.4 amp per hour scooters, so there are actually 1, 2, 3, 4 of them put in parallel, and to make 36 volts, which is the nominal voltage for these scooters, you're looking at about 10 of these parallels that are put in series to actually get the 36 volts. Now another thing is charging the scooter up to the maximum and keeping it completely fully charged is not a good idea either, because the same story, there's going to be some oxidation of the lithium ion to the aluminium, and this is going to deteriorate the cells and the life cycle span of the cells too. Now normally, if you're looking at these cells, if they are used within the parameters of the manufacturer, you are looking at between 500 to 800 life cycles. Some of them they claim 1000. If they tell me like 500 life cycles or 700 life cycles, I just decrease the number of life cycles by, let's say, 20%, because they always claim a little bit more than what is reality, because they are actually charged and discharged in these test environments in perfect conditions, perfect environment, perfect temperature. So probably you will not actually be able to recreate and regenerate the same circumstances if you're using, for example, your scooter. These batteries, they will also get warm, and heat is also something that these cells, they don't like. The materials inside, they don't like heat, so they have a limit of maximum heat that they can survive. But if the heat is too high, it will eventually make the cell deteriorate much faster. Same if it's if the cells are stored or are used in very cold weather conditions, the energy that is stored inside the cell will deteriorate as well, and it's not good for the cells as well. So that's basically it. So what do you do? What do you do with these scooters? What I do with these scooters, Basically, first of all, one more thing I need to tell you before I'm going to talk about how you need to charge them is when you charge them, never charge them unattended. You never know that something goes wrong with the BMS, and the BMS stands for Battery Management System. And what is a battery management system? It's actually a system that's going to monitor every individual pair of cells to see that the voltage of the cells are, and when it's charging, that they are charged in a correct way, and that one of these cells is not overcharged or undercharged because of the fact that I just explained to you. Going below the galvanic voltage is going to damage, and going above the 4.2 volts is going to damage the cells. And if you just apply current right here and right here, maybe the one in the middle or one here or this one here might have a higher voltage, but it will go beyond the scope of the allowed voltage that is supposed to be applied, and that they actually supposed to work with. Okay, now how do you charge them? Well, you charge up your scooter when you finish driving. You charge it up completely, and when it's fully charged, you can take off the charger, you can unplug the charger of the scooter, and the best practice is just to turn on the scooter, okay, when you just fully charged the scooter. And what happens, the scooter has a timer, and about 20 minutes later the scooter will turn off. Why is that, and why is it interesting to unplug the charger when it's finished charging? Whether it's the day after, it's not a big issue. If it's hanging on the charger for maybe half a day or one more day, it's not the end of the day, it's not the end of the world. It's just going to keep the voltage pretty high. The thing is, if you can just discharge the cells just a little bit, tiny little bit, just by turning on the scooter and leave it. And when you leave it, after 20 minutes, it's going to turn off. It has drawn a little bit of current, and the voltage will probably drop from 4.2 and maybe 2.1, 4.2.05, something like that. It's going to drop back down to 4.19 or something like that, and that actually keeps the cells within the limitations of the voltage that it's allowed to have. If you increase the voltage, if you go beyond the 4.2 volts per cell, you're definitely going to damage the cells as well. So they're not designed to get a higher voltage than 4.2 volts. While you're drawing current and while you're driving the scooter, the voltage might fluctuate pretty much. And as I explained in my previous video, we have disabled the alarm, low voltage alarm, because when you're going up a steep mountain, the voltage might just drop close to 3.1 volt or something like that, and the alarm will start to make some noise. And actually, there is still in these cells here, they can go down to 2.5 volts. So there's still a lot of energy left, although the alarm is just pointing out that it's flat, which is not the case, because when you go back on a flat road, you still have a lot of energy left over. So maybe you might hear the alarm at 10 kilometers of range, and you still have like 10 kilometers left over. So basically, just store the scooter for a long time. If you store it for a long time, maybe like, let's say 2 months or 3 months, charge the batteries, and this is true for any device that has these cells. Charge the batteries, because maybe the device might be drawing a little bit of current when it's turned off, and you leave it unattended for maybe 1 or 2 months. But I recommend when it's been sitting there for 2 or 3 months, just charge it up again. And same story, when it's fully charged, you unplug the charger, you turn on the scooter, and you just let the scooter time out, and it will turn off automatically, and it will have drawn a little bit of current, so you're back again within the specs of the maximum and minimum voltage of the scooter. Then one more thing, I also do not recommend to leave the scooter in the sunlight, because if you have the scooter on a sunny day in the sunlight, because of the black coating and the black carbon fiber, and also the deck is black, you might end up having temperatures that rise up of the cells that are beyond the scope of the allowable temperature, and might just damage the cells as well. So other things that you need to know about the maintenance of the scooter. Let me grab the camera. The wheels here, the motors themselves, they're hub motors, and the hub motors doesn't have any gear systems, doesn't have any bearings, so they're more or less maintenance free. You don't need to do any kind of maintenance for the motors themselves. And also regarding the suspension, there is no direct maintenance that you need to do for the scooter suspension as well. So that's it. That's my video about the maintenance and how to, okay, let me just put it like that, how to actually use the scooter and how to the best practice of using the scooter. So I think it gives you a very rough idea about what you should actually respect regarding batteries and maintenance. That's it, guys. Thank you for watching, and if you find this video interesting, subscribe to the channel. I will release many more videos regarding these, but also regarding the chicken that you see on the background. So see you guys. Bye bye.